My name is Antonia Reime Aab. I'm a preservation advisor and IPM coordinator at ICA Østfold Arkiv Øst in Norway. This poster is targeting Ctenolepisma longicaudatum, implementing an effective IPM program on a limited budget in a small to mid-sized institution. So, the regional archive for East Norway is responsible for 6,000 meters of archival records. In the cold and dry Nordic climate, insects have previously been a very minor issue in archives and libraries, but in 2017 we discovered an infestation of Ctenolepisma longicaudatum at our archive. We needed a new approach to pest management, and in this poster I'm going to outline how we succeeded in eliminating the species from our storages. Not only was pest infestation in itself novel to us, but this bristletail species was also novel to Norway, leaving us with limited information about its biology. We also faced the usual high staff workload and budgetary constraints that most public institutions face, forcing us to find pest management solutions that were both time and cost effective. There was also a critical lack of space, which ruled out the possibility of separate quarantine areas. The Integrated Pest Management (IPM) model was not widely used in Norway, and staff had to go abroad for training at institutions with well-established IPM programs. By monitoring with blunder traps, we found the distribution of the population that had established itself within the building, as well as discovering how new specimens found their way in, namely as stowaways in packing materials. Corrugated cardboard proved to be a particular problem, providing a very attractive combination of food, housing and transportation for this species. We established protocols for all deliveries entering the building, ensuring that packing materials were immediately disposed of. Low temperature treatment was made a standard part of the accession procedures. Following Matsson's 2018 mortality data on the species, we monitored the core temperature to -20 degrees Celsius using standard household freezers. Based on research by Ork and by Moore, the ambient temperature in repositories was lowered from 20 degrees to 15, inhibiting species activity. All accessions awaiting treatment were stored on plastic pallets and isolated using high adhesive double-sided tape on the floor for containment. This last photo shows one of the specimens caught on tape. All areas were closely monitored for pest activities with blunder traps. So, what was the outcome of our approach? Our ongoing monitoring with blunder traps and staff observations has indicated that Ctenolepisma longicaudatum has been eradicated from repositories. The table compares the numbers of specimens caught in traps before and after the IPM program went into effect at the first quarter of 2019. In our non-storage areas, we saw a 76% decrease in species over the course of a year. The numbers are shown in this table by Instar. Recording age diversity within the insect population provided us with useful information for targeted treatment as well as assessing the overall impact of our IPM measures. In conclusion, by identifying key measures, our IPM program proved to be effective while still maintaining efficient workflows and ensuring collection safety. We eliminated Ctenolepisma longicaudatum in high-risk areas within a limited budget, effectively controlling any further ingress to our institution. And for these results, I am indebted to a whole list of people. Thank you for your time.